discovery of cathode ray tube, discovery of electron for J.J. Thomson in 1897, recollecting the memories, the discovery of the fundamental particles, that is subatomic particles, cathode ray tube, and the properties of cathode rays, discovery of electron charge by Millikan's famous oil drop experiment, then V/M ratio of Millikan's oil drop experiment we all discussed in the previous classes, and anode rays, Eugen Goldstein about the proton discovery, and Goldstein perforated experiments, cathode ray tube, discovery of proton, Rutherford's gold foil experiment, which is famous, Rutherford's gold foil experiment. These are the important things what we have discussed in the atomic physics, my dear friends. And now atomic physics, the discovery of neutron, the great scientists like Rutherford and James Chadwick. Now, James Chadwick, on the right, a student of Rutherford, won Nobel Prize for his work in 1935, the discovery of neutron. I would like to give introduction to the discovery of neutron today morning, early morning. From the previous discussion, we can see that the gold foil experiment gave a clear picture of the structural pattern which consists of protons, that is nucleus, and the same number of electrons outside the nucleus. But scientists soon realized that the atomic model offered by Rutherford is not complete. It is incomplete. Various experiments showed that mass of the nucleus is approximately twice than the number of protons. What is the origin of the additional mass? Rutherford postulated the existence of some neutral particles having mass similar to proton, but there was no direct experimental evidence to prove that, and hence several theories and experimental observations eventually led the discovery of neutron. We can summarize some of the scientific observations behind the discovery of neutron. Alpha particles bombarded from the source radioactive element, then radiation, this is beryllium, and radiation, paraffin wax, the protons displaced by neutrons. So this leads to the study of discovery of neutrons. In 1930, W. Bothe and H. Becker found an electrically neutral radiation. The number of scientists contributed towards the discovery of neutron in several ways. For example, W. Bothe and H. Becker. These persons are responsible for the electrically neutral radiation when they bombarded beryllium with alpha particle. They thought it was protons with high energy, gamma rays. In 1932, 1A. Gamma rays means immediately you should think of the radioactivity, my dear friends. Radioactivity in 1933, Ernest and Frederick Joliet-Curie showed that this ray can eject protons when it hits paraffin or hydrogen-containing compounds. The question arose that how massless proton could eject protons which are 1836 times heavier than electrons. So, the ejected rays in bombardment of beryllium with alpha particles cannot be photon. In 1932, James Chadwick performed the same experiment as Ernest and Frederick Joliet-Curie, but he used many different target bombardment beside the paraffin. So these are the two scientists, Ernest and Frederick Joliot Curie, working in their laboratory, and the bombardment they discovered the Frederick Joliot in 1900 to 1958 and Ernest Joliot Curie 1897 to 1956 for the synthesis of new radioactive elements. 1930 for a Nobel Prize in Chemistry to them. Here I would like to recollect the great scientist Madame Curie. She awarded twice the Nobel Prize for his contribution to the radioactivity. Henry Becquerel, since those things will be discussed separately in the next coming classes, my dear friends. Now, James Chadwick in 1932 performed the same experiment as Ernest and Frederick Joliot Curie, but he used many different targets of bombardment besides paraffin by analyzing the energies of different targets. Bombardment, he discovered the existence of a new particle which is chargeless and has a similar mass to proton. This particle is called neutron. Beryllium undergoes the following reaction when it is bombarded with alpha particle. Beryllium 4-9 and alpha particles 2-4, that is carbon 6-13. This is called radiocarbon, my dear friends. This is artificial radioactivity. This will be discussed later in the forthcoming classes slowly. And the neutron. This is the emission of neutron. Thus, the history of the discovery of the neutron is wonderful. So, properties of subatomic particles, that is very important factor here. Electron symbol is e to the power of minus, that is charges. These are the statistics data available: electron, proton, neutron, and the credit goes to the James Chadwick, the discovery of neutron, electron, Sir J. Thomson, and proton, Goldstein and Rutherford. My dear friends, thank you.